have. And the fifth experiment is basically the simulation of a DFA. DFA would be deterministic finite automata. Deterministic finite automata. As in, suppose if you have inputs such as 0 and 1, considering that you can make only things with using 0 and 1. So if you have a particular state, the outputs would be 0 and 1 only each, once each time. In the same way, many can be received at the final state. So there is an initial state, there is a final state, there are some other intermediate states, there are also trap states in between. So trap states in between. So you can execute some grammars. You can execute some grammars using this particular DFA. Now we are going to simulate this particular DFA using a Java program. So we are giving all the necessary initializations here. So we initialize, we have imported these packages, and we ask for inputs such as the number of states that are present, number of final states, number of trap states, number of symbols in the enter the number of symbols in the alphabet. So the number of states is how many number of states. Say if it is two, it is two. Number of final state is the final state is something that when the string ends. When the string ends, that is a final state. Remember, the trap state is some state which is a waste state. Waste state. Otherwise, we can say that it is a useless state or it is an unwanted state. Unwanted state. In the same way, we put all these. We put the state which is the final state, the trap state, the singular, the final states. What states are final? The alphabets of the DFA, and enter the transitions for the given state for each and every variable. And our transition table is supposed to be generated. So enter the string in the given alphabet. So if this particular string is inputted or is accepted, then it means that a DFA is simulated properly. And it is checked whether the string is accepted. It is going to check the program. So it is going to check. So for this, what we are going to do is we are going to enter the state integers. So we are going to initialize this particular array called state, and as each and every input is added, this particular state array is going to get increased. For each, the next thing is final. So even for final, it is going to increase. The trap is also another array that is initialized, and it is going to increase. The alphabet. So alphabet is also an array that is initialized, and any alphabet that is given is initialized. So it can either be, this is going to be the name of the state. So the transition for the given state. So whatever state is there. So if you have state 0, state 1, 0 on having an input of 0, you go to which state? That is what is described over here. Next, we have the transition table generated from the output, from the input that is given on top. So we are going to run this file now. Let us enter two states. Number of final state is 1, number of trap state is 0, number of symbols in the alphabet is 2. The state integers are 0 and 1. Enter the final state for the alphabet. On input A to state. So for state 0, we are going to input A. So then it is going to go to 1. On input to B from 0, it is going to go to 0. For input A to state for the next state is going to be 0. So this is the transition table that has been generated. So if our initial state is 0, then an input of ABA is not accepted in our particular DFA. This is our experiment.